The main advantages of helium surveying as compared with other types of geological exploration work are low cost of the work, the ability to carry out surveys at locations where access is difficult, and the fact that helium surveying is beneficial and can be used at any stage from prospecting to exploration and at various stages of field production. It is also important that helium surveying is environmentally harmless. The natural field is measured without any impact on the natural world. And of course, there's the rapidity with which field work is completed and ready-to-use results are delivered. Helium surveying can be used at initial and prospecting stages as a standalone method for study of the geological section and territory. At the exploration and field development stages, helium surveying is best used together with other geophysical techniques such as seismic exploration. Such integration gives better results. However, seismic work is only carried out at parts of the territory which the helium survey has shown to be promising for oil and gas finds.
Обычно точки полевой гелиевой съемки располагаются.
The points in a helium survey are at a distance of between 50 and 1,000 meters from each other. The operator and his team find each point using GPS portable navigation equipment. After the team has found the point, the operator launches process management software on a computer. The device is configured and 30 measurements of helium concentrations in surface air are taken. While these measurements are in progress, the team prepares a shallow borehole in the ground with depth of 1 meter or to the depth of the solid rock cover. When this has been done, the operator connects the device to the sampler in the hole and 30 measurements are carried out in the hole automatically. When the measurements are complete, a file with their results is automatically created. It contains information on 30 concentrations of helium in surface air, 30 concentrations of helium in the hole, subsoil helium, coordinates, and the time of day obtained from the satellite. These data are protected by a password. Preparation of these data is fully automatic and intervention by an operator is excluded. The data obtained are collected by a responsible person at the end of the day and sent to headquarters. To repeat, the data are dispatched each day to head office for processing and for adjustment of the schedule. The head of the field detachment makes sure that instructions are factually transmitted. Our equipment is fitted with the GPS black box function.
Оснащено функцией GPS черного ящика. Программное обеспечение.
The software has been specially developed for helium surveying. It was developed from scratch. Our task was to exclude impact of the human factor to the greatest possible extent and to make sure that helium events are as reliable as possible. We have designed, produced, and tested the software accordingly. It fully controls the measuring process for more than 10 parameters and creates a result file which is password protected. The software is specifically intended for our purposes, which are to measure the natural flow of helium objectively and in situ. The software has been certified at ROS patent in Moscow and relevant documents have been obtained. Actual Geology has rights to the work, method, and the software, i.e. the helium survey technology.
Данного программного обеспечения
Предприятием «Актуальная геология» за последние 3 года было сделано.
Actual Geology has carried out 3 assignments in the last 3 years for my division of Gazprom. All of them different in terms of geology, location, and nature of the task. The first project entailed a large amount of field work and was accomplished by covering an area of 1,400 square kilometers in the eastern part of West Siberia, where there are no roads or infrastructure and the terrain is very uneven. The climate is very severe in this northern region and the survey was carried out during the winter. The area to be covered was immense and the work was spread over 2 seasons. The survey specialists were successful in discovering helium anomalies. 2D field seismic work, profile seismic, was carried out at the same time as the helium studies, and seismic results were also obtained. Comparison and collation between results of the seismic work, which was also carried out over 2 years, and the helium survey results showed that both approaches had achieved their goals. Maps were prepared using results of the two surveys independently of each other, and the maps were subsequently combined, which shows a high degree of convergence of the seismic and the helium results. The helium survey found very large anomalies in the central, northern, and western parts of the area. Seismic anomalies were also distinguished, namely the Verk-Nekudo-Saiskoye elevation and a number of small elevations which also coincide with anomalies in the helium survey. The uniqueness of the approach is shown by the fact that there are no deep drilling data for the area. The nearest wells are 60 kilometers away at the Svetlogarskia area and the northern part of the Kudo-Saishkaya area. No fields or accumulations were found as a result of drilling. Small-scale anomalies were identified by use of well logging. Well testing gave a flow of formation water, so seismic methods proved inaccurate in this instance. The inaccuracy could be about 30 meters, since seismic methods can only give indirect evidence of hydrocarbon presence. Helium surveying gives direct evidence of oil and gas presence, since it measures the natural background diffusion of helium. Seismic data for the discovered anomalies have been re-examined and larger seismic bodies have been proposed, extended traps, which even continue beyond the boundaries of the studied territory. A first well will be drilled in a new territory in the near future at a location which combines anomalies discovered by the helium and seismic surveys to the greatest possible extent. Drilling results will show compatibility of the two methods and check the anomaly data. I expect a positive result based on the very promising nature of the area for oil and gas finds and the new approach to prospecting. There is a difficulty associated with the fact that seismic exploration has made us focus on discovery of large anticline structures, while helium surveying reveals prospects associated with complex lithological structures. I am confident that the anomaly, which has been discovered in the western part of the area, corresponds to a large lithological structure complicated by a small local elevation.
Фактору, то есть небольшое локальное поднятие, так и к крупному литологическому объекту. Гелевую съемку на лицензионном участке ООО «Газпром».
Actual Geology executed a helium survey at a license area of Gazprom in the course of 2 seasons of fieldwork. The total area was 1,400 square kilometers and an observation grid of 300 by 300 meters with 11 points per square kilometer. The survey identified anomalies with heightened concentrations and intensive variations of helium levels. 2D seismic fieldwork was carried out at the same time at 2.5 kilometer intervals. Results of the helium and seismic surveys were compared. The anomalies identified by the two methods are practically identical, which confirms quality, accuracy, and reliability of the helium survey. Some of the anomalies identified by the helium survey even give broader prospects for oil and gas presence. The results of the work have been used to site a first prospecting well. Gazprom will drill the well in the immediate future.
Который рекомендуется к бурению, и в ближайшее время в планах ООО «Газпром» пробурить данную скважину. Помимо выполненных полевых работ на Верхнеходосейском
Work
лицензионном
was also
участке,
carried out for
также
my
были выполнены
division
для
of
компании «Газпром»
Gazprom
добыча
in two
«Ноябрьск»
other license areas.
работы на
The latter areas
Бухарском
are located
лицензионном
in the
участке
Urals in the
и
eastern
Кедровском
part of the
лицензионном участке.
Sverdlov region,
Данные
where the
лицензионные
climate is
участки
also
находятся
severe.
уже на Урале,
A part of the work was
на
carried
востоке
out during
Свердловской
summer and
области,
a part during the winter with snow
что
cover.
существенно
The
снижает
total volume of work was 400 square kilometers.
климатические условия, то есть
As
суровость
you can
климатических
see,
условий
only
по
two
сравнению с
fragments of the
выполненными
area,
на
the most promising
Верхнеходосейском.
fragments, are represented.
Поэтому
Total extent of the area is much greater.
в летний
What is
период
shown are the most promising segments.
по снегу.
The Bukharovskoye field has already been discovered at the area and contains gas accumulations in carbonaceous sediments which have already given inflows of gas. A network of wells have been drilled, some of which have given commercial flows of gas, while others have proved less successful due to adverse geology. Abrupt changes in reservoir qualities of carbonaceous sediments associated with a fractured zone, as well as complex geological structure including tectonic displacements with amplitude up to 250 meters. Results of the helium survey fully confirmed the results of seismic work that was carried out earlier. The anomalies that were found correlated with wells that had already been drilled, and new promising targets and arches were found, which also coincided with seismic results. Drilling has already given commercial inflows of gas at well 138, fully coinciding with the anomalies found by the helium survey. As well as assistance in locating hydrocarbon accumulations, we can also forecast zones with enhanced reservoir qualities, zones where the carbonaceous sediments are decompacted. These are hydrocarbon accumulations, and they are fully confirmed in structural terms by the seismic exploration work. The next license area, the Kedrovsky area, is located to the north. Again, only a fragment of the area is shown. The total area extends much further. A helium survey was carried out, contours of which coincided with a 3D seismic survey. There is a full coincidence between the helium anomalies and the earlier seismic data, and also with the Kedrovskoye field, which was discovered previously. Recommendations have been given for future drilling of wells. As can be seen on the map fragments, the number of anomalies at the Kedrovsky area differs substantially from their number at Bukharovsky. This is because a different grid was used, 200 meters at Bukharovsky and 500 meters at Kedrovsky. However, the less dense grid is still adequate for distinguishing anomalies. As of today, two sites will be recommended for new wells, which will be drilled in the near future. To conclude, I'd like to say a few words about the advantages of helium surveying. Firstly, a helium survey is a direct method of prospecting for hydrocarbons. Secondly, it is less expensive than 2D and 3D seismic, while providing results that converge with seismic exploration data, both 2D and 3D. The method is environmentally friendly, having almost no impact on the natural environment. Helium surveying can be used to search for hydrocarbon accumulations almost anywhere on Earth, onshore, in mountainous terrain, and offshore. Another advantage is that helium surveying can be applied when industrial development of fields is already in progress for purposes of identifying zones with enhanced filtration properties for specific exploration and production drilling tasks.